Question 5. Part A. A square matrix P is called idempotent if P squared is equal to P. Hence, show that I, B, the matrix B, which is equals to 1, 1, 0, 0, is idempotent. B squared is equals to, if B is idempotent, B squared, which is denoted by B times B, should give us the same matrix. So if you multiply B times B, 1, 0, 1, 0, it should give us the same matrix if it is idempotent. So 1 times 1, then plus 0 times 1, then 1 times 0, 1 times 0, plus 0 times 0, then 1 times 1, plus 0 times 1, then 1 times 0, plus 0 times 0, which is equals to 1 times 1 plus 0 times 1 will give us 1. 1 times 1 plus 0 times 1 will also give us 1. Then 1 times 0, 0, plus 0 times 0, which is 0. Then 1 times 0 is 0, plus 0, 0 times 0 is equals to 0. So B squared is equal to it's matrix 1, 1, 0, 0, which is the same as B, which is also 1, 1, 0, 0. So we have successfully now proved that B is idempotent. Then we now move on to P, Roman numeral 2, part 2 of A. It says P is idempotent. So the identity matrix, we are on B. We are on 2, Roman numeral 2. So if P is idempotent, we are saying that we are supposed to prove that the identity matrix, we are supposed to find the matrix P, the matrix P, identity matrix minus matrix P, which is like identity matrix minus P. Then if P is idempotent, we know that P multiply a matrix multiplied by its identity will give us Pi, or Pi which is the same as P, minus P times P. We know that P times P, a matrix times its matrix, is equal to P squared. So therefore P times its matrix times its identity will give us P. However, we know that if P squared is idempotent, as we have proved above, if a matrix is idempotent, P squared is equal to P. So therefore P minus P squared should give us 0. This you can prove this using the example given above. If you substitute B, if you say B is equal to 1, 1, 0, 0, and calculate and substituting B, matrix B for P, you still get that P, identity matrix minus P, will give you a matrix, a 0 matrix. Then we now move on to B. B states that on question B, we are told that the transverse of T minus 2 times identity matrix, or as an inverse to the power 1 or power minus 1, is equal to the matrix 2, 1, minus 1, 0. What it means is, for you to solve for for C, for you to find C, you first have to take out this this minus 1, this power 1 to the power negative 1. So how would you do that? You're going to multiply everything, raise everything to the power minus 1. So if you raise CT, which is in transverse, minus 2, the identity matrix, to the power negative 1, everything to the power negative 1, then whatever you do to your left, you also do it to your right. So you also raise here to the power negative 1, which is also, they are saying, an inverse of this matrix. Therefore, this now, we are going to have CT, because this multiplied by this is going to give you 1. So you're going to have CT minus the 2 times the identity matrix is equals to 2, 1, minus 1, 0 as an inverse. So now what you need to do now is you have to calculate now the inverse of this matrix. The inverse will be calculated as 1 over the determinant, and the determinant will be calculated as 2 times 0 minus 1 times minus 1 minus minus 1. Then you interchange 2 and 0. 0 comes here, 2 comes here, then you change the signs, multiply by minus 1, then you're going to get minus 1, then you're going to get 1 here. Then this is equals to, this is going to 2 multiplied by 0, 0, 1 minus minus equals to 1. So we're going to have 1 over 1. So it's going to be 1 here. 0 minus 1, 1, 2. Therefore, we are saying the transpose of C transpose minus 2 times its identity is equals to 0 minus 1, 1, 2. Then you take your identity matrix, you move it to the other side. We have the equation C transpose minus 2 times its identity is equals to 0 minus 1, 1, 2. Therefore, now we are saying the transpose is equals to, you take this minus 2, you take it this side. So it becomes a positive. So you're saying 0 minus 1, 0 minus 1, 1, 2, plus 2 times its identity. Then 0 minus 1, 1, 2. The identity now, 2 times the identity is 1, 0, 0, 1. That's the identity matrix of this 2 by 2 matrix. So if you add, you're going to have 0 minus 1, 1, 2, plus 2 times 1, 2, 2 times 0, 0, 2 times 0, 0, 2 times 1, 2. Therefore, you are going to 0 plus 2, 2, minus 1 plus 0 minus 1, 1 plus 0, 1, 2 plus 2 is equals to 4. So now, you now have the transpose C, the transpose of C is equals to 2, let's suppose 2 minus 1, 1, 4. Now, you want now to find out C, you are required to find C. In order for you to find C, you have to raise C to transpose, then whatever you do to your left, you also do it to your right. 1, 4. Then you also need a transpose here. What it means is C transpose raised is a transpose again, we will reverse it to become a C. We reverse it now to become a C, but on the other side you have 2 minus 1, 1, 4, that needs to be transposed. So C is equals to, now when you transpose a matrix, you take your row and make it a column. For instance, if I take the first row, I'll say 2 minus 1. Then I take the second row, I say 1, 4. Now I've transposed the matrix above. This matrix above has been transposed. So therefore, C is equals to 2, 1, minus 1, 4.